assistance. Right, so let's zoom in here a little bit. Right, so the first part of the question is asking us to show or give a reason why HJM is 38 degrees. So how do you interpret three letters, HJM? But it's actually very, very normal in maths to specify an angle with three letters. Now, if it's HJM, what you have to do is trace the three letters, and it's always the middle letter. So H, we trace it to J, and then we go to M. So HJM is actually this angle over here, right? Because the reason you don't call this angle J, if I say angle J, that could be misinterpreted very, very easy. If I say angle J, won't some people think that angle J is this entire angle? Or some people might think angle J is this angle. So to have no confusion whenever you're specifying an angle, especially in complex scenarios like this, you want to put three letters. So you get an idea, a very specific idea of which angle they are referring to. So why is this angle also 38 degrees? Now, one person gave an answer. But for those of you all who now understand what the question is asking, do you all think you all can take a try now? Why is this angle 38 degrees? All right, so before I give away the answer for this, right, let's do some quick background theory. I don't know if you all remember this from but Form 1, Form 2, it may have been part of the SEA syllabus, I could be wrong. Whenever you have two parallel lines, now the lines must be parallel for this to work. And of course, for the lines to be parallel, the examiner has to say or indicate at some point in the question that the two lines are parallel. Usually they put two arrows like this. That's the symbol for parallel lines. So whenever you have two parallel lines and you slice them, you'll notice you get a kind of Z here. Well, this angle and this angle are called alternating angles. So these are alternating angles. And alternating angles are equal. So if here's 50 degrees, this one is also 50 degrees. Now it doesn't matter if it's a nice horizontal scenario like that, even if the two lines go down like this, right? The point is the two purple lines are parallel because I put the symbol for parallel lines. So if I slice these two parallel lines, you notice you get a kind of slanted Z. This angle and this angle are equal. The one facing one direction and the other one facing the opposite direction are also considered alternating angles. And of course, they have the same exact values. Now you're going to see that scenario over here. If you look at it, right, there are a lot of lines here, right? You'll notice, look from H to J. From H to J, there's a parallel line, that's this line here. And from M to K, there's another parallel line. And you notice that the examiner, somewhere in between there, he connects these two lines. You all seen it here? And then have the little arrows to indicate that they are parallel. So if here's 38 degrees, then HJM is also 38 degrees. But I have to give a reason why, right? You have to say that HJM and this angle are alternating angles, hence they are equal. But when you're specifying the name of this angle, who can tell me what's the name of this angle here? Is it okay to call that angle M? Well, what do you all think? Do you think it's okay to call that angle M? I'm going to read through it. remember, when you're specifying an angle, you try to use three letters. So it's always the middle letter. So there are two ways to name this angle. You could call this angle JMK, or you could start by the K first. You could go KMJ. Any one is correct, right? But remember, the middle letter is where it is the one that you're concentrating on. But I'm going to go with JMK. And let me show you how I'm going to write the answer for the examiner now, right? So let me pause the video here, write it out, and then start comments. Right. So first of all, the official name for this scenario is an alternating angle. Z angles is the nickname. Please don't say Z angles. You use the official term, right? Alternating angles. Also, just to be very, very careful, to be real specific in the exam, right? HJM, remember the middle letter is the one that we're focusing on. It is usually put a little hat on it like this, like an upside down V, right? It's a minor thing, but I would prefer if you all put a little upside down V over the middle letter. That usually denotes the word angle. So this means angle HJM, right? Small thing, but could be useful in the exam. All right, so we have the answer for that one, right? I'll give you, oh, sorry, I think I'll rush in some of you, or whoever wants to write down the answers, feel free, right? Let's see what the next question is about. They want you to give a reason why MJK is 90 degrees. So let's scroll up and identify MJK. So MJK would be where? J, and we're going down to K. So it's this entire angle here. They want you to prove that this entire corner is 90 degrees. So have a look at that. You're going to have to look at the rules that I gave you in class. And let's put in the answer for this one. Remember, we just reasoned out that this angle here was 38. So I'm just writing it in because we may need it later on, right? Right. So when you go back to your rules, and I just want to point out one thing. Even though I gave you all 7 rules, remember, if you go in a different textbook, the rules are written in a different order. So whenever you find the rule that you need to use, you can't say it's rule 4 or rule 5, right? Remember, you need to write out what the particular rule is. Now, it just so happens on my notes, it's lining up with rule 3. Remember, whenever you have a diameter, and this is a diameter because it's going through the center of the circle. Remember, the diameter has to go through the center of the circle. When you have an angle starting at the beginning of the diameter, hitting the circumference, it must touch the circumference, right? It cannot miss the circumference and goes to the other end of the diameter. That angle is always 90 degrees. So it's this exact sentence you need to write for the examiner, right? So everyone look back at rule 3 and you're writing out the wording that I gave you. And if you look at it here. M to K is definitely a diameter because it's going through the center. It's starting at the beginning of the diameter, hitting the circumference and bouncing back to the end of the diameter. So this is definitely 90 degrees. And you have the wording to go with it. So I'll leave the wording there for about 10 seconds. And we'll move on to the next part of the question. Right. Part 2 now, right? we have to try to find the angle MLG. MLG. So let's go and look for that angle and see what MLG looks like. MLG. It's this angle with the dot here, right? So let me put a different color here. I'll use a purple dot, right? So we're trying to find this angle here. Find the value of that angle, right? I want you all to pay attention to a right angle triangle inside here. Let me trace it out for you guys. M, J, K, and go back to M. So let me draw that over here. Right? There's a lot of lines, and of course, it's easy to get lost inside here. Here's M, here is J, and here is K. Remember, we proved that this was 90 degrees. The examiner told us at the beginning of the question here was 38. Is it possible we can find this angle over here? All the angles in a triangle always add up to how much? 180. So I'm pretty sure that we can more than find this angle. I'm trying to color code it here, right? I'll put in a little dash here. And of course, that is this same angle over here. This angle and this angle is the same, right? So we add in 38 and 90 and minusing it from 180. I'm going to trust you all to do that one. 38 plus 50, sorry, 38 plus 90 and minus it from 180. And I am getting 52 degrees, right? So make sure you're seeing 52 degrees on your calculator, right? I'm 100% sure it's 52. Back to our rule, right? Look at rule 1, right? Have a look at rule 1 over here. Give it a read, right? And then I'll kind of try to explain it back from scratch, right? About what rule 1 is saying, right? That if you have a circle, and if you have piece of the circumference, right? Remember, the whole green line is the circumference. But let's say you have piece of the circumference. So this orange line here, from point A to point B. If you have an angle starting at point A, hitting the circumference, it must hit the circumference and bouncing back to the end of this arc here, what this is called an arc, right? Piece of the circumference, there must be an angle. Now, if you have another angle starting at A, but it hits the circumference at a different point, but still bounces back to B, you must also have another angle. What the theory is saying is that both of these angles are equal. So if here's 30 degrees, over here will also be 30 degrees. Now, the thing about it, in my particular example, the arc is underneath. But do you think it will make any difference if I drew the circle or this scenario upside down? Let's say I turn this circle so that the whole scenario is upside down, right? It's not going to make a difference. Well, let me prove it to you. So let me say you have another arc starting at here, right? The arc this time is on top, A and B. If you have an angle starting at A, hits the circumference and bounces back to B, there must be an angle. If you have another angle starting at A, it hits the circumference at a different point and bounces back to B, you will have another angle. Both angles will also be equal. And that's what's going on in this question. If you look at it carefully, the arc is from M all the way to J. Look at it. one angle starting at M, it hitting the circumference that's over here and bouncing back to J, and the angle is 52. Then you have another angle starting at M. It's hitting the circumference at L, but bouncing back to where? J. Won't both of these angles be equal according to rule number 1, right? So over here will also be what? 52 degrees. All right. So what you have to do, right, is write back this over here. Angles standing on the same arc and touching the circumference have the same side. So you have to start off with that. So everyone write back that, and then we have to expand on it, right? So I'll give you a few seconds for those who don't have the notes on. All right. So once you write the rule, right, you have to write the words hence after. Hence, right? Hence, angle JKM, hence angle JKM and angle MLJ are the same. So you write the rule and then you specify afterwards that these two angles are the same. But you notice how I wrote the angles, okay? Right, so adding that, I'm using the word hence. In some textbooks, right, instead of the word arc, they will have the word chord, right? Because if you have an arc, you can connect the two arcs, one end of the arc to the other end of the arc with a coordinate. But the point is the two angles standing on the same arc, or some people might view it as the two angles standing on the same chord. Different textbooks have slightly different explanations. Both are correct. Okay. All right. So we have, as I'm going, I'm updating my diagram, right? Let's see what the next question is about. The next one, they want you to find angle LJK. So let's go and identify that angle, LJK. Let me get a different color here. LJK. That's this angle here. You see the small angle here? They want you to find that angle over here. Get back. All right, so let me help you out a little bit more. Let me isolate this isosceles triangle, right? So let me pull that aside by itself. Here's G, that's here. We're going to M, then we're going back down to L. Remember, the examiner put two lines there, so he clearly is trying to indicate that that's an isosceles triangle. Now, these two over here and over here, what you call the base angles. Remember, in an isosceles triangle, these two angles will always be what? Equal. So if here is 52, then over here is also 52. So look at this. Well, what the examiner is trying to say is that this whole angle over here is supposed to be 52 degrees from here, sliding all the way across here is also 52. If over here is 38, how much again do we need to make the 52? How much is this blue angle here? Right? It's a simple subtraction question, right? Oh, I'm just waiting on a few, right? And a lot of people are getting it correct. It's 14 degrees. So let's word that out for the examiner. I know they ask us for this angle, but we'll get to this angle just now. We need this 14 in order to get out this angle. Now, how are you going to write this for the examiner? Give me a few seconds to word it for them purposes. Right, so this is the explanation so far of how I got the 14 degrees, right? Great. Once you reach there, I don't know if you all realize this. You all notice that there's an arc over here. Let me use a different color here. This one was hard for me to see. To be honest, it took me a while to see this. You all notice there's an arc over here. I put it in deep red from L to K. Okay? There's an angle starting at K. It hitting the circumference at M and bouncing back to K. Then there's another angle starting at L, hitting the circumference at J and bouncing back to K. Isn't that rule 1 again? So you have to write back this statement again and then say, hence, LJK is also how much degrees? 14 degrees because of rule 1. So over here is 14 degrees, that little dot over there. Right, so you have to write back rule 1 and then say LJK is 14 degrees. I think a question like this is worth more than 2 marks, but that's all they gave you. So we found LJK. We have one more to do. Hold on. When will this question finish? JHM. All right, JHM. Which one is that? Oh, that's this guy here, JHM. Well, this one is easy, right? Well, I'll put the question mark. That's what they want you to find. This one is super easy. It's actually one of the rules you have to use. Right? So the rule you want to focus on to find this last one where the question mark is actually rule 4. The opposite angles in a cyclic quadrilateral add up to how much? 180. Not too sure if you're seeing the cyclic quadrilateral here. I know there's a lot of lines, right? But if you start at L, you hit M, you hit H, G, and you come back to L, isn't that a cyclic quadrilateral? Because all 4 corners are touching where? The circumference. The opposite angles must add up to how much? 180 degrees. So you just have to take the 52 and minus it from 180, and I guarantee you will see 128 degrees. Right? For those who got it wrong, well, I hope you understand it now. All of that, right? So have fun with this question. I'm trying to make it fit, right? The first part of the question is so let me explain what a bearing is, and that might probably help a little bit, right? So the word bearing, it kind of deals with north, east, west, and south. They're just like in geography, right? So let's pretend you have a compass here. You have your north, your east, your west, and your south. Bearings are a way to give very specific directions, and then specify the directions with an angle. North is always 0 degrees, always. And you are only allowed to turn in a clockwise direction, never in an anti-clockwise direction. So anytime they give you a bearing, like they tell you, well, north is 0 degrees, so east is 90. If it keep turning like this, south would be 180. If you continue to turn to west, that's 270 degrees. And if you go back to north, that will be 360 degrees. So if I ask you to turn on a bearing of 152 degrees, and let's say 152 degrees will be in between what? North and east, east and south, south and west, west and north. Which 2 directions would 152 be in between? Right? Right, Risha, correct. Right, Sahana, right. Right, and Dina, correct, right? And a lot of people are getting it correct because 152 is in between 90 and 180. So if you're sailing a ship and I tell you to turn it to 100 on a bearing of 152 degrees, right? Well, we're just approximating today, right? That means you're going to move the ship this way. Now, what angle is 152? The angle is always measured from north, that's your starting angle, and you turn, 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 turn. And this entire dashed angle is 152 degrees. So we could reason out other angles just in case we need it for calculations. Let's use some common sense here. What would be the value of this yellow angle if I ask you that? Let me just say we needed that yellow angle. What would be the value of that yellow angle? If the whole thing is 152 and up to east is 90 degrees, how much again do we need to make 152? Let's try to reason that out, just in case. Right? And a lot of people are getting it correct, right? It will be 152 minus the 90 because the whole thing is 152. We already completed 90. So it's 152 minus 90. And this yellow angle is 62 degrees. Easy, right? How about this angle here, this green angle? Let me say we needed this green angle over here. What would be the value of that green angle between the bearing and 180 degrees? How much would that angle be? From north to south is 180. We have already completed 152. How much again do we need to make the 180? Right, and a lot of people are getting the correct answer. So it's 180 minus the 152, right? Because the whole thing is 180. We have completed 152. What's the balance? Minus it, and you will get 28 degrees. And parents, is real easier. Just remember, you're always facing north and you're turning clockwise. That's all you really have to remember, right? Using all of that now, you all want to try to interpret this diagram again, right? For those who wasn't able to. I'll just zoom in here a little bit, guys. So the first thing they told us, right, there was the starting point over here is L. So one ship sailed from L to R on a bearing of how much? 65 degrees. So that means the north is the starting point. So from north to this line, what they're saying is that is 65 degrees. Simple enough. Now the next ship also started at L, but they turned on a different bearing, a little more. Instead of 65, it's 148. But the second ship has to start from the north line and begin to turn until it begins to sail in this particular direction. But that blue angle was how much? 148 degrees. So I color coded there. So that's the diagram, right? But they want us to find the angle RLT. RLT is the middle angle. RL, and well, this is the letter T. I know you all can't see it down here, but it's written down here, T. So they want this middle angle over here. In other words, let me color code it now. They want this green angle. How much do you all think that angle is? If the whole blue angle is 148 and the red part is 65, how much do you think the balance is? The in between there? Simple reasoning, right? You just have to minus the 148 and the 65, and you will get 83 degrees. So the middle angle there, RLT, is 83 degrees. Simple as that. Now what the examiner is asking you to do in the next part is calculate the distance RT. Now this is where your homework comes in, right? RT is this length over here. Try to figure out if you need to use the cosine rule or the sine rule. I'll give you a hint. You notice you have two lengths, 250 and 180, and the angle in between them. The angle in between the two lengths is 83. So go back to your rules that you made when you did the homework. When you have two lengths and the angle in between, which rule is most likely that scenario? Rule. Right? So, I mean, based on some of the answers, I guess a lot of people didn't get time to, well, to view the trick videos as yet. But once again, I'll encourage you all to make sure and get it done before the year is finished, right? So what we have to do is put in the common letters. Here's capital L, R, and T. If here's capital L, this side is common L. If here's capital R, over here is common R. If here's capital T, the side opposite is common T. So we're already trying to find common L. So if we're trying to find common L using the cosine rule, we're supposed to put L squared is equal to R squared plus T squared minus open brackets 2 by R by T multiplied by cosine. If here's common L, the last letter is always the capital version of it. Right? So this should refresh your memory. Plug in the values, and remember, when you work out this side, you have to square root your answer. Right, so when I work this out, I get this crazy number here. I throw across the square to get the square root. And my final answer is 289.71 kilometers. So this is 289.71 kilometers. Oh, I put kilograms, sorry, kilometers. Right, so let me show you how to interpret this question, right? So we're standing at R and we want to turn to face what? T. So let me show you what I mean by that, right? Make it here a little bit smaller, right? So here's what's going to happen now. You're standing at R. So you pull out your compass, okay? So you can pretend you pull out a compass over here, with your north, east, west. Well, I won't put any the east, west, and south. So let's make the diagram a little too complicated. So you're facing north initially, and you want to turn until you face the direction of T. So you turn until you reach this line over here. They want you to figure out the size of the blue angle. Here's the hint. To figure out this blue angle, I would suggest you all try to find this brown angle here. Do your best to figure out that angle. And I'll give you our next hint. Use the sine rule to figure out that angle. Right? Remember, we're trying to find angle T, so we definitely keep in the T's. So it's T on sine capital T. I think we need to keep the L's because we have so much information on the L's. Look at it. We know common L is 289.71. Remember, we found that just now. And we know capital L is 83. We don't have much information on the R's. We have common R, but we don't have the value of capital R. So I think we keep in the L's and the T's. We throwing away the R's. So substituting the values, common letters are the lengths of sides, capital letters are the angles. Substituting the values and cross multiply. All right, so let's substitute in some values here. Common T is how much? Common T is 250. Capital T, we do not know. Common L is how much? Common L is the 289.71, and capital L is 83 degrees. So what we could do, right? You could probably find sine 83 first on your calculator, go to 3 decimal places, cross multiply, and solve for capital T. That would be my advice, but work with 3 decimal places while you are calculating, and at the end of the question, then you can round off the 2. So sine 83, are you all getting, I'll write it in just now, 0.993. If we go to 3 decimal places, you can try it out. Sine 83, this is what I am seeing on my calculator, 0.993 to 3 decimal places properly. Now we cross multiply. So when we cross multiply, we'll get 289.71 multiplied by sine T, and then you multiply this diagonal. 250 multiplied by 0.993, and we're getting roughly 248.25. This is a multiply, throw across your multiply, you will get a divide. Divide these two, you will get a decimal, then sign inverse the decimal to get angle T. Some stuff. Right. So when I divide these 2 items here, this is what I am getting. To 3 decimal places, 0.857. And now I have to sign inverse that. So when I sign inverse that to get angle T, the sine inverse of 0.857 angle T, I am getting this angle, 58.98 degrees. Right now, I'm going to stick with my 2 decimal places as my final answer. I'm not going to round it off to 59. Let me just check down here. They didn't ask us to round it off to the nearest whole number. So I'm keeping my 58.98. Right, so let me put in that value over here. This value here is 58.98. Right. But remember, don't lose track of what the question is asking us for. They want us to find this blue angle. Right, so watch me zoom in here. If I continue this line downwards here, right? Do you all think you all can find this angle here? How much is this red angle here with the dot? Remember, if here is north and I go straight down, this is south. If this whole thing is 148, how much is the balance to reach south? Check it back, Risha. From north all the way to south is 180. I have already completed 148. Won't it be 180 minus 148? I am getting 32 degrees. Make sure you understand how I get the 132. From north to south is 180. The blue line is 148. So it's just 180 minus the 148. 32 degrees. Now tell me something, right? If I have another line here, another north-south line here, I'll put it in dashed so it'll be easy to see. Right, that's another north line. Won't 2 north lines automatically be parallel? Do you all see a Z angle over here? Do you all see a Z angle? You have a north going up here. That's this north line. I'm not too sure if you all seen it. A Z angle here. How much is this dashed angle over here? From here to here. If it's a Z angle, it's 32 degrees. Correct. This is 32, Z. How much is this angle here? If this whole angle is 58.98, if this angle is 58.98, and here is 32, do you all think you all can calculate this angle over here? Whole thing is 58.98. Right, we're getting 20. Oh, that's all. I see slightly different answers coming up here. Well, sorry, 26.98. Right. Do you all see another Z angle here? Zip, zip, zip. You all see that there? Here's the 26.98 and this little angle here from here to here. Do you all see another Z angle? I know this is kind of hard to see. How much is this angle over here? Right. So this angle is also 26.98. So shouldn't it be real easy to find the bearing now? Right? To find the bearing, we're going from north, we're tracking the blue line here. We're going, we're going, we're going, we're going. Once we reach south, we know that's 180 degrees. And after the 180, we have this little extra to go. So shouldn't the total bearing be 180 plus the 26.98? How much is the final answer now? 180 plus the 26.98. And I am seeing 206.98 degrees. And once again, I feel so sorry for the people of this year. Look how much drama you had to go through in order to get that. Right? I want to point out questions don't usually come this difficult. Right? They don't usually come this difficult. All right. So the homework over the holidays is to kind of make sure you understand trigonometry. So you're going into the maths classroom. And when you scroll down, you're going to look for trigonometry. That is lesson 10 inside the maths classroom. When you click on lesson 10, it's quite a few videos from 31 to 39. Please ensure that you have it by January, and we will be opening back on January the 9th. We have one last maths class tomorrow, Tuesday at 6:45. Everybody is invited to come tomorrow. We will be doing the last question on the past paper, question 10. Feel free to fall in if you just want to follow along and finish the past paper. All right, guys, I won't hold you back too much. Take care, and if I don't see you, have a good Christmas.